Okay, so I'm going to do two examples here of integration with long division. Okay, so it goes like this. So you're going to take, if the input that you see on the integral is a polynomial over a polynomial, and the degree of the top polynomial is greater than the degree of the bottom polynomial, then you could do long division to rewrite the input of the integral. Okay, so I'm going to go down here and I'm going to take the input of the integral and I'm going to do long division. Now I put a 0 at the end because I'm missing a constant term. So any terms that are missing in the top or the bottom, you have to replace them with a 0, like a 0 coefficient. All right, so 3x minus 5. And guys, I finally figured out, I had the automatic focus on all this time, so that's why the video was always focusing in and out, but I figured out that that was the problem and how to turn it off. So you won't, unfortunately it's so late in the year, but you won't see videos anymore where it's focusing in and out all the time. Okay, so 3x, so 6x to the 4th divided by 3x is 2x to the 3rd. And then you multiply, so that's 6x to the 4th minus 10x to the 3rd. Okay, and then you gotta subtract. So I'll distribute the negative now so that just the signs change. Those cancel. 3x to the 3rd. Bring down the next one. 3x to the 3rd divided by 3x is x squared. Okay, I'm not sure how Delta Math reviewed it. I'm kind of assuming they reviewed it the way I'm saying, but the way I usually think of it myself, maybe you could do it either way, but 3x times what makes that? X squared. For some reason, that is easier for me to think of. Okay, and then I multiply this back to here. So 3x to the 3rd minus 5x squared. And then you subtract, so I'm changing the signs. Those cancel. 6x squared, bring down the next one. 3x times what makes that? 2x. Do the multiplication, so I'm distributing that back to these. Minus 10x. Or then you subtract, so I'll change the signs. Those cancel. 12x, I'll bring down that 0 that I put in there. And then 3x times what makes 12x? 4. So 12x minus 20, then I'll subtract, those cancel, 20. Okay, so you keep going till you get the term that is 1 degree less than this. Okay, so basically till you can't divide anymore. So then this is the remainder. So now, and if you didn't practice long division, if you're confused about what I'm doing, go back to the previous phase on Delta Math and that'll review how to do long division. And then I go back up here. So actually this integral here, what I just figured out from the long division is that is the same as 2x to the 3rd plus x squared plus 2x plus 4. Okay, so that's what I got up here. Plus the remainder over the original denominator. Okay, so just like that. Then you split up this integral. You split it up because these we can just use the power rule for antiderivatives on. And then this one here we can use f prime over f on. So, okay, yeah. So this, all right, so I'm going to split this up and I'm going to bring this 20 out front of the integral also. All right, so this is the integral of 2x to the 3rd plus x squared plus 2x plus 4 dx plus 20 integral of 1 over 3x minus 5 dx, okay? And now, so f is 3x minus 5. F prime is 3. All right, so in order, all right, so I want this here to be F prime over F, so I need a 3 on top. So you can do 3 over 3. We've done this before, guys, so I'm going to do it kind of fast, all right? So I multiply the top by 3, and I multiply the bottom by 3, but then I kind of want to bring, if I multiply the bottom by 3, you know, I want to pull that 3 in the denominator out front because I want to have F prime over F. So when I pull that outside, it's like that. We did this slower when we learned the F prime over F formula for the first time, but this is, since we've done it before, I'm just gonna do a little bit faster. Okay, so now we have F prime over F. All right, so now I'm gonna do the antiderivative of everything. So this is, so 2/4 is 1/2. I'll just do it fast, or a little slower. So 2/4 x to the 4th plus 1/3 x to the 3rd plus 2/2 x squared plus 4x plus 20 over 3. Now the F prime over F formula says if you're doing this antiderivative, it's the natural log of the absolute value of the denominator plus c. And we've got to know that formula. So when I do the antiderivative of this part, it's natural log absolute value of 3x minus 5, and then plus c. You need the plus c, guys. This is not a definite integral. A definite integral means area under the curve. I am about to do one of these. An indefinite integral means finding the antiderivative family. Okay, so the c is what makes this a family of functions and not just one function. All right, the c could be any constant, and if you take the derivative of this, you're going to end up with the original like input of the integral or something equivalent to it. All right, so now I'm going to do another one. Okay, so here, this is a definite integral. So we want to use the fundamental theorem of calculus. So the fundamental theorem of calculus is what tells you that to find the area under a curve, you find the antiderivative of that curve, and then you plug in these endpoints and you do subtraction between them. That's called the fundamental theorem of calculus. It was a huge discovery when it was made by separate people actually all over the world. Not all over the world, but in different parts of the world. Okay, I think like 2 people actually. I don't know. Well, we'll talk about the history of calculus a little bit after our exam is over. Okay, so we've got a similar situation. This is, if this were flipped, 9x to the 4th, or no, if this were flipped, if this were x minus 2 over 9x to the 4th, if you had a polynomial over a monomial, then you could just split it up like into terms, like this term, but since we've got the top degree is greater than the bottom degree, and these are both polynomials, we can do long division. Now 9x to the 4th is missing a lot of terms. This polynomial only has its leading term. So I'll show you how to deal with that. So it's going to be 9x to the 4th plus 0x to the 3rd plus 0x squared plus 0x plus 0 to the 4th, to the 3rd, to the 2nd, to the 1st, constant term. Okay, so you fill in all of the missing terms, x minus 2. X times what is that? 9x to the 3rd. Distribute it. 9x to the 4th minus 18x to the 3rd. Subtract. 18x to the 3rd. Bring down the next one. X times what makes that? And then multiply. Okay, then subtract. All right, so those cancel, those cancel. So 36x squared, bring down the next term. X times what makes that? Minus 72x. Subtract, those cancel, 72x, bring down that constant, plus 72. 72x minus, oh shoot, 72 times 2. Oh my gosh, I'm not even gonna. 72 times 2 is 144 minus 144. Do the subtraction. Those cancel, 144. Okay, now, so we can rewrite this. And you know what? I'm not going to rewrite the whole integral. I'm not going to rewrite one integral right now. I'm just going to do the integral from 3 to 5 of this, and then I'm going to do plus the integral of the remainder over the original denominator. So I'll split it up right away. So this is the integral from 3 to 5. Oh boy, I'm definitely going to need a calculator for this. Guys, with the integrals, when I say no calculator, I mean like don't use Math 9. You can use a calculator when you're doing the arithmetic at the end, but don't do Math 9. Don't do the calculus itself with a calculator. Okay, so 9x to the third plus 18x squared plus x plus 72 plus 144 over x minus 2. Okay, so I'm going to do, all right, well, first let me rewrite this one. So f prime over f. So f is x minus 2, f prime is 1. So in order to have f prime over f, I just have to pull the 144 out front. Okay, so pull out the 144. All right, so then that's a 1. So then I do have f prime over f. Okay, so, all right, so I do the brackets. 3, 5 plus, this is, I'll bring down the 144, brackets, 3, 5. Okay, now this is the fundamental theorem of calculus. So you put the antiderivative in here. This whole process we're doing with the brackets and getting the answer is the fundamental theorem of calculus. So in here go the antiderivatives. So 9/4 x to the 4th plus 18 over 3 is 6. Yeah, okay, so 18 over 3 is 6 plus 6x to the 3rd. 36 divided by 2 is 18. Okay, 72x. And then for this one, it is natural log absolute value of x minus 2. Okay. Now I'm going to plug in 5. All right, so this is, all right, so I'm just gonna like do it in my calculator, this part. So I'm plugging in 5. So 9/4, 5 to the 4th plus 6 times 5 to the 3rd plus 18 times 25 plus 72 times 5. That's a big number. I know it's a fraction. So, or I'll just use the decimal because this decimal is exact because there's only 2 decimal places. All right, so I'll just say here I plugged in 5. Plug in 5. Now minus, so I'm going to plug in 3. So I'm doing second enter. So that's going to be 72 times 3. That's going to be 18 times 9. This is going to be 3 to the third. And then that's going to be 3 to the fourth. All right, 722.25. 722.25. All right, so plugged, just for our notes, I'll say plug in 3. Plus 144, natural log of the absolute value, so plug in 5 and you get 3, minus natural log, absolute value, plug in 3 and you get 1. And guys, the natural log of 1 is 0. Okay, we need to know that. So this is plus 144 natural log. Guys, 3 is a positive number anyway, so you don't need the absolute values anymore. Now I'm doing 2966.25 minus 722.25. Okay, so this is 2244 plus 144 natural log of 3. That is the answer. And guys, as I was doing that problem, I looked over here. Okay, simplified. I meant to simplify. So this is, but you don't have to. X to the fourth plus 1/3 x to the third plus x squared plus 4x. Okay, simplified. Okay.